Yo, hello? Oh, this is on. Sweet. All right, guys. Hey, what's up, everyone? How's it going? How's it going? Thanks so much for coming here. I am here to share with you a little bit more about how to build on CosmWasm on top of Osmosis. I'm Sean, happy to be coming at you live. If you're watching at home and live here as well in the audience, I do DevRel here at Osmosis. Yeah, I'm here to just talk to you a little bit about how you can build your next app via this really cool smart contract enabled feature on Osmosis. So I just want to kind of walk you through a little bit first about what exactly is CosmWasm, like how it works. In the smart contract sense, I'm sure you've probably heard about smart contracts maybe in the context of like Ethereum or something like that. So I'm going to kind of differentiate a little bit here, and then we can dive into a little bit of booting up a starter DApp, making some modifications to that starter DApp to make it a little bit more complex, and then we can wrap up with some good old-fashioned Q&A. Sweet. So getting started here. The whole reason why you kind of want to start building with CosmWasm is because you're building on a very interoperable ecosystem with a lot of custom logic, right? So, CosmWasm, like as I said before, enables smart contract functionality, which is not necessarily enabled on every single chain. And CosmWasm itself and building with this tool is actually quite new in the first place. CosmWasm uses Go, and you have to be familiar with Go and Rust, so you don't really have to learn a completely new smart contract development language. With those hopefully familiar languages, you get access to lower gas fees. Just because Cosmos itself has lower gas fees, better security because it's essentially designed so then. Commonplace security issues such as reentrancy is essentially just not really an issue anymore. It's it's a very kind of interoperable tooling that allows you to kind of interact contract to contract, almost effortlly. When you're kind of taking things to prod, it's going to be a lot more like stress-free. You don't gotta worry too much about the security semantics between like inter-contract calls. There's this thing called CosmWasm bindings, or specifically Osmosis bindings here that I'm going to go over that allows you to kind of directly interact with special features from the chain itself, which is also really kind of unique, chain specific, but also along with that kind of general Cosmos interoperability merit. So. At the moment, really building custom DApps is hard. If you want to, let's say if you're moving in from a different ecosystem, ETH, Solana, etc., and you want to start building like a completely original DApp on top of like Osmosis, right? It's difficult because people, when they typically start thinking about building on Cosmos, they think of starting your own new chain, right? And like kind of all the semantics with chain dev and like custom modules. Besides from just, I guess, like figuring out how your actual chain works in the first place, getting validators and all that stuff is really difficult to kind of bootstrap your ecosystem, right? And so CosmWasm allows you to just kind of build on top, like starting immediately. As well as, kind of some difficulties with, kind of your front-end interfaces when you're, again, interacting with custom modules, as well as this general thing being new in the first place, which is why I'm here. So a little bit of why you want to build like on top of Cosmos right now with CosmWasm. As you know, Osmosis is a really like liquidity-rich and kind of like I guess deep liquidity ecosystem. So when you do take stuff to prod, it's going to be it's great. Once again, just because of good kind of adoption. And a really kind of expansive ecosystem where you have some of the brightest minds here. I'm talking about my colleagues, not necessarily me. And here to help you out with various grants, support, etc. So what I really also want to kind of highlight here is this kind of like organized like customizability. I know that typically in the past if you've ever deployed a smart contract on, let's say, like Ethereum, you get to define your custom errors. What if you also got to define the messages and kind of like what messages can go to your smart contracts, how your smart contract handles those messages, as well as even like how your smart contract tracks state. Like I know that those come in kind of in the forms of like just naturally through like functions. You don't really have to like specify anything on like an environment like Ethereum, but this is just a lot more customizable, and all the following shown on the screen. Hopefully you can see it. I'm not sure the resolution is good enough, but all the following shown on the screen is in Rust. So I think it's not too difficult to shift over. And also just additional information before our demo time. So I'm just gonna actually go over here to my code editor. I already have, by the way, this template repo is up on the Osmosis Labs GitHub. I made some slight modifications to it over the past few days just to make sure that it's ready for this demo. But yes, as you can see, I've been doing a little bit of testing, but maybe the first thing that you want to do is kind of start booting up your local osmosis, right? So local osmosis, if you're familiar with just like local blockchain environments, it's just like a way for you to get like all the benefits of having an actual blockchain to deploy on, except it's localhost. So you can, local osmosis, by the way, the setup for that is in our documentation. Oh yeah, can I zoom in? Sure. Let's hope that zooms in a little bit. Is that good? Sweet. All right, I'm gonna assume that you all have Rust set up. If you don't have that, all good. Install the latest version of Rust and then run some commands. Essentially, that'll like make your Rust run properly. Oh yeah, this is docs.osmosis.zone for whoever wants to follow along and kind of get this. I'm just gonna, I suppose the top of the screen is kind of, a little bit hard to see, but docs.osmosis.zone, you go to develop, and then you go over to building DAPPs and CosmWasm and local osmosis, and this should have, essentially is like a really quick guide, just full of instructions on how to get your local environment set up, and then start kind of like iterating and starting to build from there. So besides for just your initial Rust setup, which I will kind of, for the purposes of time, assume that most of you in the audience have set up, the next thing that you need to set up is local osmosis, and shout out to all my teammates that were working on this, because this is truly a great tool. So you copy this into your terminal, you paste it in. I'm not gonna like run it at the moment just because I've ran this before already. This should take you to this like nice little like client window. You just select 3. That essentially just kickstarts your local osmosis node download, and it should take around like 10 to 20 minutes. It's definitely not like syncing to like a Geth node or something like that. Much more time consuming. Anyways, so once you've done that, you just got to do docker compose up, which of course you also need to make sure that you have Docker and you have Docker running. This will kickstart your Docker container, and let's hope this works, because and just kind of like as a general tip for people out there who are also doing this. You should, whenever you're logging off your computer, please do make sure that you remember to just like, stop your Docker container. Just makes load up for next time a lot easier. And if you essentially get to like a really high like block height and your machine starts having difficulty kind of starting to sync with your local osmosis, it's always perfectly fine to just do like a factory reset essentially on local osmosis and just re-download it. It'll make it a lot easier. So as you can see here, I'm at block height 745. Before this, I was at like something like 6,000 before I did like a factory reset. And as you can see here, it's pumping out some good blockchain activity, because that's what we all want, right? Before we start doing our local template kind of stuff. So I would also so of course feel free to git clone this on GitHub, and then after you've made sure to update your your Rust, you can then type in the command CosmWasm. There's a script that essentially makes sure that CosmWasm compiles all of your contracts, and you can even actually you should probably even try to optimize it via either this or this Dockerized optimizer. I guess this is just as far as I know, this just goes for gas savings and just makes your deployment kind of more prod-like, I guess. So I also definitely recommend doing this. So you thought you were going to see my password, weren't you? No, I'm just kidding. So just do that real quick. Oh, question?
Do you zoom in on this at all?
Oh, yeah, totally. Sorry about that. Oh God, it's the swirling beach ball of death. Let's hope that. Okay, good. We are hopefully able to zoom in here. If not, I will try to move the window a little bit more. That way you can you guys read that actually? Is that fine? Sorry? Wait. This? Wait, can you clarify your question? I can't hear you.
You're running back, right? He's saying do command plus to zoom in.
Oh yeah. Yeah, you know what? Hey, that's a good tip. I actually I straight up didn't know that. I was like, yeah. I guess I never needed to zoom in on my own, so thanks. I know, I genuinely appreciate that. That's actually a good tip to know. So, sweet, with our enhanced resolution, let us continue the journey. So next thing you need to do is create a local key. You should create two, just because, I mean, with the contract that we're going to be deploying now, you only need one, but having two is always good for testing kind of token transfers and kind of balances and value flow and all that. So you can all you got to do is just do osmosis the keys, and then you add and then you do your key name. So I already have test 1 and test 2. You can do this for yourself as well, and get test 1 and test 2 up and running. Oh, you know what? You should probably also make sure that you have Osmosis D installed. I forgot to mention this because Osmosis D is just kind of it's just your kind of normal local environment. I'm pretty sure it actually comes with the initial setup step that we did, but just make sure that you have that installed. But yeah, just Osmosis D keys add, and then your key name. And afterwards, you can do osmosis keys list to check your keys. So, anyways, maybe it'll probably give you some sort of response like this. You could just type in your password a bunch of times, and then it will just after that you'll be able to see the amount of keys that you have. As you can see, I may have done this a little bit, more times than one, just to make sure that everything's working. But you should just have test 1 and test 2. So what you should do next is then cd into a folder called artifacts, right? And then you can. I'll just also show what exactly artifacts is. Artifacts is where your WASM file got compiled. And so what you can do here is you can essentially deploy this right now using this compiled WASM file. And what you should do is actually skip this step, come down here, and make sure that you essentially you would deploy this with your like, I think this records your like transaction hash or something. But yeah, your transaction hash. But make sure that you have that logged as well as your code ID. I wouldn't dare just try to like recite this from memory because I haven't been doing this for like 2 years or something to memorize all this. So I just like to consult the documentation. I copy this. And I make sure to just replace some of the various values here with my own. So here you can have, I'll just deploy this with test 1. And then for your chain ID, you can do local osmosis. Yes, okay, sweet. This file name is just the file name of your like WASM, like compiled like WASM file. It should vary depending on like what you name your contract, but it's named this in this example. So as you can see, it's the deployment's going through, and if you also just do this to get the code ID, you'll also just get your code ID. Nothing much to change about this command for like getting code ID. So we'll just continue moving here. So this is a completely brand new contract. Your value should be 1 for like your code ID because just you've done this once. Next thing you should do is send a instantiation message to your contract. It's like it's what I like to think of. It's like a constructor value, right? For like I guess in general. So what you do here is you can set your initial state. We're using kind of like a counter example. So like count from like I guess 1 to 10, and every single time you like call like a function, then it'll just increase the count by 1. So you set that to you can set your initial state to 100, and then execute this code to make sure that your contract gets initiated with that count 100 as the kind of constructor argument. And by the way, you for every single message you send, you need to make sure that you're sending it from like a specified test key, as well as your you also specify your local osmosis chain ID. So just like what we've done before. All right, and there it goes. There's the contract instantiated. You can then get your contract address. This command is also kind of like copy and paste, and it's not very it doesn't change much over the course of like multiple coding instances. So you can also fetch your contract address. Your contract address is then used for your various function calls. So down here, you can query your contract and interact with it. You can you do like a get query where you like get your contract state, and that would kind of come in the form of like osmosisd query wasm, and then something in the end, right? I think contract state and smart are also just included. But anyways, kind of you can probably see the pattern here being like, okay, I use osmosisd like txwasm, and then this is kind of the maybe this can be tx. If this is like an execute message, you put tx here. But if this is like a query for contract state, you just put query here. So you kind of see that, I guess, like that kind of pattern, right? Depending on what you want to do, you just specify the specific message type that you want to like execute and have happen, and then it'll be fine. So I'll just kind of do this just to show you that it works. So we're gonna set this get state message to like get count, right? The get count function, as you can see specified right here. Sorry, I'm just gonna zoom in a little bit here as well. All right. count. Right. So this is like a query, right? And then you have a query message specified here, get count, that makes sure that it returns a count response containing your the current contract state of what is the count, right? So you set that get count, get state message, and then you can send it off using what is specified in the documentation here. And this obviously doesn't apply for just this demonstration. This applies for whenever you want to, send a message to a contract. You can first specify your message via get state message, or you can set a variable for that, and then specify your message here where this is highlighted. And of course, with different getter functions, or I guess whatever function you're calling, this is going to be different. But yeah, you can make sure that this happens, and then send your message off in a similar format to this, and it'll just work. So as you can see, this we get our count is 100 as we initialized, and then we can then include a increment message, which is just increment, and then you can put this in. Oh wait. Oh yeah, sorry. From your test key. C1 here is just like a test key number, or test key name. So you can just replace that with whatever test key you're using. Confirm the transaction, send it, and if we query again, the count will be 101. Great, sweet, congratulations. If you followed along, you did your very first, very, very basic interaction with, CosmWasm contracts in general. But now we're kind of going to dive into a little bit of more specific things and talk about how you can build with, specifically with osmosis bindings on CosmWasm. So I'm just going to kind of git checkout to my branch here. Okay, I guess we're just gonna delete a few files here and there because we don't need to keep these. Of course, I'm low-key and high-key kind of a Git noob, so if y'all have any advice, let me know. But yeah, anyways, so we managed to check out over, and we can just open it up and see what we have. Actually, yeah, it's already open. Sorry. This contains essentially just a few things. Your typical imports are here still, but with one exception. We have this use Osmo bindings thing, and how do we get this to actually work? You have to make sure that you have osmosis bindings as a dependency in your cargo.toml file. This goes for if you want to. I'm not quite sure what this testing is for, but you at least need the Osmo bindings, as an actual dependency, not just a dev dependency. All right, sweet. So now that we have this, it's time to essentially just do what we did over again. So we just cargo wasm, and that should build and compile the contracts. There should be a few warnings here and there. That's just because, this is, I kind of ripped this from the the actual contract that I just showed you, the example contract that I just showed you, and added some osmosis bindings features to it. So we have this, and it's finished compiling. And then what we can do next is cargo schema, right? Before seeding into your artifacts folder, you can actually do cargo schema to make sure that you have all of these. If your messages are well defined at this point, and you know exactly what's going to go in and what's like how things should respond. There are these essentially schema types for like your execute messages, query messages, even kind of that constructor thing that I was talking about where you initiate your contract. Right, so that's just kind of like, it's all part of the setup. And by the way, it's actually really convenient because the script will remove, if you have duplicates, it'll just remove those and start over. Next is you head over to try to actually instantiate this thing and deploy. So as you can see, we have our hello world.wasm file here. This is, by the way, this is actually poor naming convention. You should, because these are being like going to be used as cargo traits, you should actually do CW underscore your contract name, and that can be defined. That can actually be defined here in the cargo.toml. So I believe it's somewhere here. It's here. So the name is hello world. You should probably just change that over to like CW dash or something like that. Anyways, naming conventions aside, let us continue bootstrapping this this DApp. And by the way, let's kind of also just take a brief look through the actual contract itself. That way, you kind of have some more information besides for just like how to boot up DApps. You have your typical like instantiate function that we just went over, except this time your dependency will also take in this like kind of template-y looking like Osmosis query thing. And what this does is it actually contains several useful things like API, and as well as essentially other things that are being injected from CosmWasm that are essentially necessary for your contract to get responses from the Osmosis chain itself when you're doing like chain queries, because all of the following functions, such as like create, denom, change admin, and all that stuff, are all Osmosis. Like you're interacting with the Osmosis chain. So let's actually just kick this off as well. And so, by the way, these create, denom, change admin, mint token, and burn token, like bindings, they're there. Like in kind of this list. I'm pretty sure in the documentation there's a list of what bindings are currently like implemented. If you want to create like your new own like custom binding that, let's say if it's like a feature like join pool or exit pool that Osmosis already has but hasn't implemented quite yet as a binding, you do that via a PR to the Osmosis. To the Osmosis Labs like bindings page or repo. So there's two kind of PRs here, and you just need to make sure that you include some sort of tests to make sure that it works, as well as the actual binding, like new query itself, as well as some of the things that it should respond with, when you do make that query. So let's make sure that this thing works, and I want to leave a good amount of time for Q&A as well, so we can kick this off. So as you can see, we just now did cargo schema, and now we can execute a initialization message. So what we can do here is, and again, I would not dare like just do this like on my own because I don't actually remember all the various different things. So I like to consult the documentation for that. So you do this. Obviously, your test key might not be test 1. so you can just replace that, but everything else should be about the same. Okay, so if you get an RPC error, let's see what's going on here. Failed to queue message, error parsing into. Okay, so it seems like some elements of what we did previously has somehow remained into in the actual in the code base. So if that happens, you can feel free to actually just reboot. You can delete the folder and then reboot it from scratch, and I think that'll be fine. Just because there are different messages, and you can you should probably probably the simplest thing would be just to start fresh, check out that different branch, and then continue from there. So I'm not going to save the changes. I'm actually just going to try this again just to make sure. Yeah, okay, sweet. So we can actually just port this over from here. Yeah, and then what I can do is just head over to CW TPL Osmosis, move that to trash. Yep, and then we can just check out that branch. And sometimes that happens, but that's interesting. I was testing that before, and somehow it didn't happen to me. So let's just do a quick little reboot and then start again. And then git checkout. Sweet. Okay, so let's do cargo awesome. All right, and this is going to take a small while. And while I do this, are there any just questions in the audience or chat or anyone? No, all making sense so far?
Yeah. Do you also think CosmWasm takes longer than optimized version or not?
Oh, sorry?
If you run CosmWasm, does it take longer than running the optimization? So using the Wasm side?
Yeah. Cargo, yeah, you should probably run the optimized version. That might actually take a little bit less time. Yeah, so this part, essentially, right? Yeah. I probably should have done that. Thanks. Sorry. Right, so you just do that, and it should, just compile everything. The reason why I recommend starting with this template is just because if you want to check out, oh, that's the actual osmosis, but there's already quite a few kind of necessary, almost necessary dependencies already installed for you. So let's see here. Yeah, in the cargo.toml file. So, most of this actually, the CosmWasm, STD, storage, CW storage plus CW2 and all that. Most of this I didn't actually have to change. I just added in Osmo bindings, and that was it. And so, right. So once this builds, which should be pretty quick.
Could you recap what the difference is between this contract and the contract previously?
The difference is for this one, we're using the actual osmosis bindings. In the previous one, that was just hey, how do you get started with CosmWasm in general, and how do you interact with the contract? But for this one, your CosmWasm binding, your osmosis bindings allow you to interact with essentially unique aspects of the Osmosis chain in the form of its unique like modules, and like the messages that you can send to those modules for them to do special things, and that varies chain by chain. And the reason why the kind of reason why you would want to again use these bindings is it's probably the most direct way to like build on top of Osmosis. Because like the default, at least like before like pre-bindings, is like would you like fork the Osmosis repo or something like that and make modifications? Like, I don't know, it seems like a lot of overhead to me, you know what I mean? So, yeah, I think this is a pretty direct way to just build on top. But, the lucky thing is Osmosis bindings work basically the exact same as, how you would do with normal, like, CosmWasm code, except just a few differences with how you basically bring it in and make the contract accept and kind of process these query data and responses. So, and what I mean by that, first of all, probably the most obvious is like you have to import Osmo bindings as like a dependency, and then in your source, even your errors are also different, right? Like. I may or may not have shown this earlier, but your errors with the token counter was very, very little, right? It was just like, hey, is this unauthorized and is there a custom error? But with, now with the Osmosis bindings, you now have like all these various different like things relating to, in this example at least, like tokens, right? Like, is this an invalid subdenom, like does this even exist? Can you even, if you can't burn tokens from another address, what happens then? And as well as different messages that you have to define. So, your create denom message, is, it's kind of needless to say, it's obviously different from just like a message to increase your, your counter, which is tracked by the, contract state. Just by itself, and even when you're kind of defining your state, it's different. As I was like saying a little bit earlier, you can define what state your contract tracks, and here you no longer have to track a int32 value of count, but you still have to track your owner, and you don't necessarily have to like handle like, hey, who gets what. Unless you're building like something like a staking DApp, for example, where you need to like say like what's the amount of tokens, let's say, that like this account has deposited into this contract, right? Like that, then you would need another sort of like tracker that's like, hey, that tracks that kind of state. But you can kind of see here how much customization, I guess, there is. With just how your contract handle things. Right, so, okay, sweet. So, I just did CargoWasm and Cargo Schema, which generated for me a bunch of these like, JSON schemas for how these messages that you send to, along with your, your Osmo bindings, how these messages basically look and how they should be processed. And so what you can do next is continue along with the process. And you can, just like we did last time, send a instantiate message to the contract. And so let's hope this works. My local Osmosis should be still running. Oh wait, you need to actually, I don't think I actually deployed this yet. So I need to make sure that I deploy this. So you can deploy it via, just once again from the documentation here, your TX and your code ID, make sure you have these. And you can just change relatively minor things. So change this to hello world.wasm according to what like the wasm file's name is, and then test one local osmosis. Yep, and that should be, I think that should be good to go. Oh wait, oh sorry, you have to, how could I forget? You need to cd into your artifacts folder first, and then run this. All right, and you know, just as expected, this is the way that, well, it works. So similar kind of deploy process, except you know you just used, you know, your bindings inside your contract, and then you can just continue following along with the README, right? You instantiate this contract. You know, so then after you send that, you can log down your contract address, which is necessary for executing the rest of your various messages, such as creating a denom. Press yes to confirm the transaction. And yeah, you can, and as you can see, we just created a denom, and we can you can even try to mint some tokens. So this is just like another random, like, you know, address that we can mint some tokens to. And if you do that, you know, after executing our last like mint token message, you know, this is here, and you know, the amount is 100. We just minted 100 tokens, and you know, kind of the message structure is once again a little bit similar, right? You know, mint tokens amount 100, denom, like the denom that we just created, mint to the address of our test2 key. So there you have it. A little bit, just it's kind of like a 101 here with you know, how do you do CosmWasm, and you know, how do you do osmosis bindings. And by the end of today, you should have learned just how do you deploy like a really basic like token factory, or even like just token counter contract, as well as starting to use kind of the base, you know, the basic you know, binding functionalities that we offer. You know, kind of there are more things currently being built, so let me elaborate a little bit on that before this presentation comes to a close. So the future, as I like to say, is, you know, more tooling. You know, like you know, building CosmWasm contracts is still a relatively new thing. So there's going to be Beaker, what is currently being built. It's essentially like a DApp development environment. If you come from Terra, then you would be familiar with Terrain. It's essentially something similar. And a lot of more DApp building tooling, such as, for example, for any of you security fans out there, you might understand that there is something like, you know, static analyzers for security vulnerabilities like Slither, right? You know, and it's tooling like that, but also, you know, like as well as front-end tooling to interact with your contracts that's currently being built out right now. You know, and you know, if you want to do also front-end related material, there's more related on that on the documentation, which uses Osmo.js to you know, kind of interact with your contracts on the front end. And I'll just show you that really briefly before I move on. So right here, JavaScript in smart contracts, right? So you install CosmWasm, and so this class CosmWasm client exported from the CosmJS package. You know, learn more in the official docs. And here is essentially, you know, this might look familiar to you JavaScripters or, you know, TypeScripters out there. And so you can have, you know, various functions that, you know, kind of expect responses from the chain itself, such as get the block height or get the chain ID or, you know, stuff like that. And when you're querying your smart contracts, or even wanting to build out like smart contracts functionality into your DApp, you would essentially just try to do a similar thing. You have this client, and it connects to your localhost RPC endpoint, and it's just like await client.get contract, for example. This is just like a really basic get contract function. But once you've gotten that contract, you can then have a function that's like get count, right? Connects to your RPC endpoint again, and then it queries the smart contract, and then it includes that little snippet of that message that we originally sent at the end, and it console log. When you console log the result, it should be whatever the current count is. So that's how you would do like front end related stuff. If you want to bake this right into your front end, so that's possible. And regarding, once again, the future of what is coming, I didn't get the chance to build out like a front end for this demo, but there will be more workshops, videos, etc. in the future that will focus on kind of front end specifically. And last but not least, if you are building a project, hit me up, let me know what you're up to. I'm always very happy to help you, actually get down and help you, for whatever questions you have. So after this very tedious or kind of long workshop, I just want to thank you for being here. Thanks for staying, and giving me your attention and building CosmWasm with me. Thanks.